Welcome to section 8.3, Simple Interest. Objective 1, calculate simple interest. Interest is the amount of money we get paid for lending or investing money, or the amount we pay for borrowing money. The amount deposited or borrowed is called the principal. The interest charge, expressed as a percent, is the rate assumed to be per year. Simple interest involves interest calculated only on the principal and is computed using the following formula. Interest equals principal times rate times time, or as you'll see it a lot throughout your text, I equals PRT, where I represents the interest, P represents the principal, R represents the annual interest rate and is always written as a decimal, and T represents time in years. For example, suppose you deposited $1,000 in a savings account that has a rate of 3%. To find the interest at the end of the first year, we would use the formula I equals PRT, where P would be the amount you deposited, 3% would be your rate, and you want to find the interest at the end of the first year, so 1 would be your T. When you multiply all these values together, you get $30. So at the end of the first year, the interest is $30, which means the total balance in the account would be $1,030, which is the original principal, the amount you deposited, plus the interest earned, which is $30. Simple interest is used for many short-term loans, including automobile and consumer loans. When dealing with loans that don't last a full year, we must express time as a fraction of the year. Okay. So imagine that a short-term loan is taken for 125 days. The time of the loan is 125 divided by 365 because there are 365 days in a year. This fractional representation of time is important for accurate interest calculations. However, before the modern use of calculators and computers, the banker's rule allowed financial institutions to use 360 in the denominator of such a fraction instead of 365 because it simplified interest calculations. While this rule is less commonly used today due to technology, understanding it helps explain certain historical lending practices. Let's do some guided examples. So let's say you deposited $3,000 in an account at your town bank, which has an interest rate of 0.9%. We want to find the interest at the end of the first year. Okay? So our principal here would be the 3,000. Our rate would be the 0.9%, but written as a decimal would be 0.09. And time would be 1 because we want to know the interest in the first year. Okay. So now we need to find I. So I equals P times R times T. So we'll be multiplying the 3,000 times 0.09 times 1. When we enter these values into our calculator, we will get 27. So the amount of interest at the end of the first year is $27. All right. A student took a simple interest loan for $2,400 for 2 years at a rate of 7%. What is the interest on the loan? So this student took a loan for $2,400 for 2 years. So that means the time is T at a rate of 7%. So as a decimal, that's 0.07. So to find the interest, because that's what our question is asking us, what is the interest on the loan? I equals PRT. So substituting in my values into this formula, I'll get 2,400 times 2 times 0.07, which comes out to be 336. So the interest on the loan is $336. Objective 2, use the future value formula. So when a loan is repaid, the interest is added to the original principal to find the total amount due. And this total amount, the original principal plus all the interest accumulated, is an important value in financial mathematics. So the amount due, which we give the value A, or the letter A, is called the future value of the amount borrowed. In other words, P is also known as the loan's present value, which represents what the money is worth today, while the future value represents what you will owe or have in the future after interest has been applied. So the future value A of P dollars at a simple interest rate R for T years is given by the following formula. A equals P times 1 plus RT. And this formula combines the original principal with the interest earned over time in a single calculation. So let's break down what each variable represents. So A is going to represent your total amount, so your future value. P is going to be the principal or the present value, the original amount. R is going to be your annual interest rate. Remember, this is always expressed as a decimal. And T will be your time in years. So in our guided examples, our first one states that a loan of $2,040 has been made at 7.5% for 4 months. We want to calculate the loan's future value. So we know the future value here is the letter A. So let's list out all that is given to us. So we know the principal of the loan was $2,040. We know the rate is 7.5%, which is 0.075. And we know the time is 4 months. Now, time is given in years, so we need to represent this as, or in years. So 4 months out of 12 months would be 1/3, or 0.33, repeating. Okay. All right. So our formula, A equals P times 1 plus RT. Okay, so let's substitute in our values. 2040, 1 plus 0.075. And since my fraction is repeated as a decimal, I'm going to keep it as a fraction so it can utilize the whole value. Okay. So when I enter this into my calculator, remembering to keep all of my parentheses, I will get 2090.49. I need to round to the hundredths place because when we deal with money, we only have 2 decimal places to the right of the decimal place. So my total for my future value is $2,090.49. All right. So, in addition to jeopardizing your health, cigarette smoking is a costly addiction. Let's consider, for example, a person with a pack-a-day cigarette habit who spends $7 per day, 7 days each week on cigarettes. How much is spent on this item in a year? Okay. Well, there are different ways that we can solve this problem. I'm going to show you 2. So the first way is we know that this person has a spending habit where they spend $7 per day. Okay. And then they spend it 7 days per week, okay? And we want to know how much is spent in a year. Well, there are 52 weeks in a year. Okay. And so now we're able to simplify by canceling out our units. So weeks divided by weeks is 1, days divided by days is 1, which would give us the amount per year, which is exactly what we're looking for. Okay. So 7 times 7 times 52 is 2,548. Another way to solve this is we know that a person or this person is paying $7 per day. Okay. And we know that there are 365 days in 1 year. So now my days cancel, leaving me with the total amount per year. Okay. So 365 times 7 would also get us roughly 2,555. Okay. So these are approximately the same. Again, they're estimates. One uses exactly 52 weeks, and the other one uses 365. Okay, but both processes are correct. So if this person now invested the yearly spending on cigarettes in a savings account with a rate of 1%, how much would he be or she have saved after 1 year? Okay. So in our previous problem, we solved this 2 different ways. We got 2 different answers because one used the rate between days and weeks, and then weeks and years, while the other one just used the conversion from days to year. So depending on which process we take, we could get different amounts. Okay. So we know that we want to know how much will be saved after 1 year. So we want the future value. So we know we're going to be using the formula A equals P times 1 plus RT. Now, depending on which process we're going to take, it's going to look a little different. So for the first process, our P is going to be 2,548. But in the second process, our P is 2,555. Okay. Our R will still be the same at 1%. So that's 0.01. And our time will be the same because we're just trying to see how much would be saved after 1 year. Okay. So now we want our future value. So the future value for the first principle, 2,548, and then we multiply that by 1 plus R, 0.1 times T, which is 1, will get us $2,573.48. And the future value, if done the second way, 2,555 times 1 plus the rate times time will get us $2,580.55. Again, depending on the process that you take, you could get 2 different answers. But regardless, this person will save a lot more money if they were to invest the money they used to buy cigarettes into a savings account. Okay, let's do a couple more. Say you borrow $5,000 from a friend and promise to pay back $6,800 in 2 years. What simple interest rate will you pay? Okay, so we know now that we're looking for the rate because our question is asking us what would the rate be. So we know the future value, that you are paying back to your friend. That's 6,800. We know the principal for what you started out with, the original amount, which is 5,000. We know the time period in which you are going to pay them back, which is in 2 years, but we don't know the rate. That's what we're looking for. Okay. So our formula is A equals P times 1 plus RT. So let's substitute in our values for each letter. So 6,800 is A, P is 5,000. Then we have 1 plus R times 2. So that would be 2R. Okay. So we now have to simplify because we need to find R. So let me rewrite this so that we can see this a little bit clearer. So 5,000 times 1 plus 2R. There we go. All right. Now, first things first, let's distribute the 5,000. We need to break up that quantity in parentheses. So that would be 10,000 R. Now we can subtract 5,000 to the left. So if I subtract 5,000, I'll get 1,800 equals 10,000 R. Now I need to divide both sides by 10,000. I'm going to write that over here. So that would get R by itself. All right. And then I want to simplify R into a percent. So I want the decimal value of this. So that would be 0.18 equals R. So then R equals 18%. So the simple interest rate that you would pay in order to pay back 6,800 would be at 18%. Okay. All right, next. How much should you put in an investment paying a simple interest rate of 3% if you need 4,000 in 6 months? Okay. So we know our rate is 3% and we need 4,000. So that means this is going to be our future value and our time period is 6 months. Okay. So A equals 4,000. R is 3%, which is 0.03. Time is 6 months, but we need it in years. So that'll be 6 divided by 12, which equals 1/2 or 0.5. Okay. And we don't know P because we need to know how much we should put in. How much should we put in? That's what we're trying to find, which is P. Okay. All right. So we have our formula. A equals P times 1 plus RT. Let's substitute in the values that we know. 4,000 equals P times 1 plus 0.03 times 0.5. We can simplify what's in the parentheses. So this would be 1.015. Now we can divide both sides by 1.015 because that would get P by itself. So now P equals 3940.886. Okay. But we want to round to 2 decimal places, so to the nearest cent. So we are going to round up, okay, because this is going to ensure that there's enough money to meet the future goals. So our principal will be $3,940.89. All right. Awesome. And that concludes section 8.3.